In this lesson, we're going to explore different network topologies, but before we do that, we need to talk about some key terminology. The first one that we want to explore is a node. A node is anything connected to the network, usually a computer, but it could be a printer, scanner, or another device with network connectivity. A segment is any portion of the network that is separated by a switch, a bridge, or a router from another part of the network. The backbone is the main cabling of the network that all the individual segments connect to. Usually, the backbone is capable of carrying more information than individual segments alone. A topology. The topology is the fashion in which each node is physically connected to the network. These devices as a whole usually create a structured model. The first topology we're going to talk about is the bus topology. A bus topology is where each node is daisy-chained or connected one right after the other along the same backbone. We used to use this topology a lot with coaxial cables, but it was eventually replaced by 10^-T twisted pair. Information sent from a node travels along the backbone until it reaches its destination node. For instance, if the first computer wanted to talk to the last computer in line, that communication would have to go from the first computer through all the intermediary computers to get to the last computer in the line. Obviously, if there's a break in the network, somewhere between that first and last computer, all communications would stop. The next topology is the ring topology. The ring topology is similar to the bus topology in that the rings have nodes that are daisy-chained together, but the end node is connected back to the first node, creating a complete circuit. Each node takes turn sending and receiving information through the use of a token. That information travels around, and you guessed it, a ring. Only the node with the token is allowed to send the data. All the others must wait for the token to come to them. This technology was traditionally used in token ring and FDDI or FDDI technology. You will still see this technology in some service providers today, but you won't find it in a local area network. The next network topology we're going to talk about is the star topology. In a star network, each node is connected to a central device called a hub or a switch. This hub or switch takes the signal that comes from any node and passes it along to the other nodes in the network. Now, in this traditional design, the length between the hub and the node is dictated by the Ethernet standard. There is an additional topology called an extended star topology that adds a repeater between the hub or switch and the spoke or node on the spoke to extend the maximum transmission distance. These designs have several benefits. First, new stations can be added quickly, and second, a single failure won't bring down the entire network like it will in a bus or a ring topology. The next topology that we're going to talk about is a mesh topology. In a mesh network, each node is connected to every other node. It provides great redundancy, but it also adds a lot of complexity. For that reason, we don't find this used in a lot of today's network. In order to calculate the number of links that we need in a mesh network, you would take the formula n times n minus 1 divided by 2 to calculate the total number of links. So in this scenario, we have 4 nodes. So we plug that in for 4 times 4 minus 1, 3, which is 12, divided by 2 comes up with 6 links. As you can see, as you scale this out to 10 nodes or 100 nodes, it becomes quite complex. Sometimes we see a partial mesh used in WAN connections today for redundancy. The final network topology I'd like to talk about is spine and leaf topology. I don't believe this topology is covered in the exam, but I would feel remiss if I didn't mention it to you because it's an up-and-coming technology in the data center space. In this topology, each leaf node is connected to each spine node in a redundant manner, forming a topology in which information only has to travel a maximum of 2 hops to reach its destination. So, if I want to send information from this host to the other side of the network, I only have to go 1, 2 hops. This network or fabric is high performance and it's designed with today's application needs in mind. Traditionally, we designed networks for a lot of north and south communication and some east and west communication. So that north and south communication would be servers talking to end users. Today, we have a lot more east-west conversation, which is servers talking to other servers in the data center. And this network topology is going to start to become more and more prevalent. Please join me for our next session on how to interpret network diagrams.